Hello everyone, this is my first video and today I'll be teaching Calculus II / Calculus BC. So we're going to be talking about a main topic in calculus, which is limits. So first we're going to understand what a limit is. Oopsie. We're first going to understand what a limit is graphically. So a limit basically tells you the value of a function as you approach some value of x. So for instance, in this example, let's say we're trying to find the limit of f of x as we approach a. So that would look like this in notation. And we could see as we get closer and closer to a from both left and right side, we get to L. So that would be our limit. Something else we should understand about limits is that even though the limit exists at a, it is not guaranteed that f of a exists. So in the graph we have a hole at a, which means f of a does not exist. Another thing that could happen is there could be a hole, but the value could exist. But when this happens, the limit at a and f of a do not equal each other. Because the limit tells you what happens as you approach some value of a. And in the graph, we could see we're approaching L, not whatever this could be. In this first example, we found the limit graphically. Oh my god. But now we're going to find it numerically. So here we have the function f of x equals 2x minus 2 divided by 4x squared minus 4. And let's just say we're trying to find the limit. Oh my god. The limit as x approaches 1 of that function. So unlike the previous example where we could use the graph, my graph isn't so good. So we're going to have to find it numerically. To do that, we make two tables for values to the left and right of your a value, and in this case it's 1. So we want our numbers to get closer and closer to 1 as we go down. So first we would do like 1.5. That is in the wrong side. 1.5, 1.1, 1.01, 1.001. And on this side we do 0.5, 0.9, 0.99, 0.999. After we find f of x at these values of x, we could see a constant trend that they both tend to go to 0.25. So from that, we could say the limit of f of x as x approaches 1 is going to be 1/4. Since we were just talking about values left of a and right to a, oh my god, right to a. Since we were just talking about values left and right of a, let's go to left and right side limits. So consider the function f, which is equal to a piecewise function where x is equal to 3 when x is greater than or equal to 4 and x equals 1 when x is less than 4. So if we were to take the limit as x approaches 4 of f of x, which one do we pick? Do we pick this one or this one? For right now, I won't tell you why, but it does not exist. We have to consider the left side and right side limits. So for the left side, we just go left of our a value, which is 4, and we could see it's going to be 1. But if we go to our right side, as we go from the right, it's going to be 3. And basically, the reason this does not exist is because the left side and the left and right side limits do not equal each other. Another type of limit that we should understand is asymptotic limits. What this is just a limit at an asymptote. So consider the function f of x equals 1 over x. Just on a side note, it's really helpful for this class if you're able to like picture a function in your head without having a graphing calculator. It's just helpful to know that. So we should know that this function looks like that. It's tiny because I don't want to draw a big version. But if we were trying to take the limit as x approaches 0 of 1 over x, 1 over fishy, 1 over x, what would it be? So it's a similar case to this left and right side limit, because if we go to the right of 0, it's infinity, and the left is negative infinity. So we would say it does not exist. But now, what if it looked like this? What if it looked like that? Now the function would be 1 over x squared. And since the limit from both left and right side is both infinity, this would be equal to infinity. I hope you see why I like it. It's a very simple problem. But let's get back to it. So now we're gonna go over some like a weird funky limit, which is called, well, I call it oscillating limits. How do you spell oscillate? I think that's right. Oscillating limits. So this could be found in any trig function, any normal trig function. So that includes sine of x, cosine, tangent, secant, cosecant, and then cotangent. This only happens when you have a trig function of like 1 over x, or something in the 1 over x form. So for example, if we have sine of 1 over x, the graph would, like, it looks funky. You have this on the left, let this be -1, and then this be +1, and this on the right side, right? And then as it gets to 0, it just becomes this. It literally looks like that. So in that case, where it oscillates like that, there's no value for it, because as you get closer and closer to 0, it oscillates faster and faster. So it'll always be between -1 and 1, because that's the range of sine of x. I'm gonna discuss, this is gonna be a direct lead-in into the next unit, which is 1.6. And these are non-calculator limits. What that means is you can't use the numerical way to find these. And an example of this would be the limit as x approaches 0 of square root x squared plus 9 minus 3 all over x squared. So after filling in our charts with values of x that gets closer and closer to 0, we could see our function gets to 1 over 6. But if we were to keep going even closer to 0, we get 0. So our answer is 0. But that's actually not the case. It's actually 1/6. We have to do these limits analytically, which we will learn in the next video. But now let's get into some practice problems. So for our first problem, let's do a numerical limit where f of x equals square root of 16 x squared minus 6.25. Let's say we're trying to plus 6.25. And let's say we're trying to find the limit as x approaches 0 of f of x. So let's make our box x f of x. Something that we can notice about our function is that it's even, which means it's symmetrical along the y-axis. So we can just do plus or minus whatever value we input. So let's do 0.5, 0.1, 0.01, 0.001. And for our function, we get 3.201, 2.53, 2.5001, 2.500. So as we get closer and closer to 0, we get 2.5. Now let's do my favorites again, the graph limits. So in this problem, this is our function f of x, and we're trying to find the limit as x approaches 1. The limit as x approaches plus or 3 from the left and right. The limit as x approaches 3. And then f of 3. So let's start with f of 3. F of 3, we have this bold dot here, so it's just going to be 3. The limit as x approaches 1, it's right here, we get 2. Okay, left and right, let's do the positive one first. So as we go from the right side of 3, we get closer and closer to 4. So that's our positive limit. And then from the left side, as we get closer to 3, we get 1. And then the limit to 3, since the left and right limit are not equal, it does not exist. Only 2 problems. This is pretty simple. So yeah, that's it. Bye-bye.